Okay, so as we just learned, the sine law lies to us. So I want to find the angle of x. So I'm going to do that, and I'm going to do that. And I can clearly see that in this diagram, because it's given to me, that this is an obtuse angle. So let's see what happens. So I'm going to say that sine A over A is equal to sine B over B. So I'm looking for angle x, and that's over 80. And sine of 10 over 30. So I'm going to solve for angle x. So I'm going to isolate. I get sine inverse 80 sine 10 over 30. And then I'm going to solve for x. So I'm going to grab my calculator and do sine inverse bracket 80 sine 10, and we're going to divide that by 30. I'm going to close that bracket, and I get 27.58. But clearly this is an obtuse angle and not the acute one that sine gave me. So I'm going to say, but the angle is obtuse. So x is equal to 180 minus 27.58. So I'm going to do 180 minus 27.58. And I get that clearly the angle is 152.42 degrees. Okay, so on the back there's a think about it. I'm going to give you a hint. So a pedestrian is walking down the sidewalk when she spots a lawn sprinkler, 10 meters away at an angle of 15 degrees in relation to the sidewalk. The spray radius is 5 meters. What length of the sidewalk will be wet? So she spots it. Here's my sprinkler. So clearly it is 10 meters away. Says it makes an angle of 15 degrees to the sidewalk. Radius means that this has to be some sort of circle. There's my lawn sprinkler. And the radius from here touches the edges of the circle. Radius means that this distance and this distance have to be the same. And in the question they tell me they're 5 meters. And I want to know what distance of the sidewalk is wet. So basically I'm looking for this part right here. How much of this is wet?